Okay, so in tonight's episode, we're going to talk a little bit about continued fractions. In Roger Penrose's intriguing book, The Road to Reality, he sets out to take the reader on a voyage of discovery through all the mathematics that underlies the mathematical physics of today and beyond today. And early on in that journey, he decides to take a look in at the ancient Greeks and talk about their concept of the relationship between numbers and lengths, because of course you can't measure lengths in terms of numbers, and it had been established by Pythagoras that the square root of 2 didn't have a fractional representation, and that was kind of a problem. So what we're going to do is discuss how you can solve that problem with the continued fractions. And in particular, we're going to show that the square root of 2 is equal to this continued fraction that I'm writing here. Okay, so let's do that. Let's start by writing out, we want to prove that this thing on the right is the same as the square root of 2, okay? So we're going to call the thing on the left x, and we're going to write simply that the rest of the formula unchanged for now. We're going to do this nice and slow. Okay, now we want to get it so that the thing on the left and the thing on the right start to look the same. Let's move the one to the left just for now. And now we can make a remarkable observation that this whole continued fraction is, in fact, exactly the same as this subcomponent of the continued fraction. So we can replace this whole thing by x minus 1. Let's do that. X minus 1 equals 1 over 2 plus 1 over... No, we've gone too far. 1 over 2 plus x minus 1. Okay, now it gets kind of easy, because we can just say this is 1 over x plus 1, and then we multiply out x minus 1 times x plus 1 equals 1. So x squared minus 1, I'm assuming we can multiply this out, equals 1. So x squared is 2. So x is plus or minus the square root of 2. And it can't be the negative square root of 2 because everything in our original equation was positive. And that's the proof.